the electric potential as a function of distance x as shown. Construct a graph of electric field strength E. So the given figure is potential versus distance x, and we need to construct the electric field E versus x. To construct this one, first we need to know the relation between electric field and potential and the distance. That we know that electric field E equal to negative of potential dV by dx. So which also you can say that negative slope of V versus x curve. So here dV by dx, so this is nothing but slope. Now the curve V versus x curve here from 0 to 1, if you can observe carefully, now it is a positive when the potential is increases and the distance is also increasing. When the potential is increasing, so distance is also increasing. So I can write that from 0 x less than 1. Since potential is increasing, so therefore distance is also increasing. Therefore dV by dx, which equal to, it is having positive slope, positive constant. If dV by dx is positive, what about the electric field? From at here, the electric field E equal to negative constant. So I can write that electric field E equal to negative. When we draw the graph, that we have to plot in the negative side. So let me plot that first to make you understand. Suppose if I take curve, so this is positive x-axis, and if I take that as this is negative x-axis. And if this is an electric field, now I have to start negative electric field from 0 to 1. Suppose if we take that from 0 to 1, so this will becomes my negative electric field. So here it is 0, here it is minus E, and here the value goes to 1. So that is the graph, the line we have to draw. Since the electric field is constant, so that's why we have to draw a straight line from the negative E to up to 1. Now let's see what happens for the next case. From 1 less than x less than 2, between the case, it means in this case. So here we can see the potential is constant, straight line. So if it is a constant, potential equal to dV by dx equal to constant. What is a constant differentiation? Constant differentiations equal to 0, because dV by dx equal to constant, so therefore constant differentiations goes to 0. So the electric field, E field equal to 0 from the 1 to 2. So how can I represent that in the graph? So if it's a 0, so I will take another color to highlight that line on the x-axis. So this is the 0 line. I'll take straight line from here. So from here to there, that is 0. I hope it is visible. Suppose if I take from up to here to there, so that line goes to 0. So this is number 2 from 0 to, sorry, 1 to 2. I made a thick line so that it can be visible. Now for the third case, means from 2 less than x less than 3. In this case, if you can see, the line is falling down. It means when when the x is increases, the potential value decreases. When the distance is increasing but the potential value is decreasing, so I can take this as a case. Therefore dv by dx is having negative constant. If the dv by dx is negative constant, what about the electric field? Electric field is negative of negative, so electric field becomes positive. So in this case, I need to draw electric field as a positive E value. So for that, if I take that a line in the curve, suppose here if you take a positive E, now we have to draw a line at up to there which is positive, and from there, oops, it is supposed to be straight. Just draw a straight line. Now from there we can draw a constant line. Now it is up to the value 3. So if you can combine C together, the potential versus an electric field, if the potential is increases, the electric field is negative, and if the potential is constant and the electric field is remains constant, and if the potential is decreases, again from that value the electric field is again increases. So this is the potential versus x curve, and this is the electric field versus x curve. So these are the corresponding values of the zeros, and the zeros, here it is 1, and here it is 2, and here it is 3. 1, 2, 3. So that is the variation of the electric field versus potential. How the potential is increases or decreases, so depends upon the variation of the potential. Electric field is also changes. Why? Because the relation electric field equal to negative of rate of change of potential. So the negative sign shows where the electric field increases, where the slope is steepest. Means that negative sign shows us the direction of the electric field. The direction of electric field indicates where the potential is steepest.